students, so today we are going to start another chapter, or even I could say another division of physics. Okay, so this chapter's name is thermal properties of matter, and thermal properties of matter will come under thermal physics. Okay, we have studied initially motion in one dimension, motion in a plane, laws of motion, work power energy, rotational motion, gravitation. All these things will come under mechanics. Okay, they are called mechanics. So here we are going to start another new division of physics, which is called thermal physics. Thermal physics. In thermal physics, we are covering 3 chapters of NCERT. One is this chapter, thermal properties. Then we study thermodynamics. Third chapter we study kinetic theory of gases. Kinetic theory of gases. All these 3 chapters putting together we call thermal physics. So in thermal physics we are going to enter into the first chapter. Okay, so you know thermal properties means what? The properties associated with the temperature or heat, we can say. Thermal means something related to heat and temperature. Okay, so before this chapter, before thermal properties of matter, you know we have studied mechanical properties of solids and mechanical properties of fluids or liquids. So for that we say elasticity, fluid mechanics, many names we have said, but exactly the correct name is what? Mechanical properties of solids. Then what? Mechanical properties of fluids. So why this is mechanical? Because here force and what? Work is involved. Force and work is involved. So here work is involved, so and force is involved. That is why we call them mechanical properties of solids, mechanical properties of fluids. Now here in thermal properties we are going to study about, I said already, about temperature and heat. Okay, so what is the difference between temperature and heat? Okay, so temperature is the measure of hotness. Both are not at all equal. Heat is actually energy. Heat is energy. Okay, its unit is what? Joule. And temperature, no one will say temperature is energy. Temperature's unit is joule or calorie. Temperature's unit is what? Kelvin, degree Celsius or degree Fahrenheit and all. So these both are different. This temperature is the measure of hotness of a body, and this heat is an energy. What kind of energy is heat? We can say heat is the energy in transit. What do you mean by transit? Transit means traveling. You might have heard about transit visa. Okay, so the transit visa means the visa in order to travel. When you travel to another place, you will have to get down at one airport, and to get down at that airport, okay, different country, before moving to the destination, you need a transit visa. So likewise, transit means something which is traveling. So heat is an energy in transit. Okay, that is the correct word. Heat is an energy in transit. Okay, energy in transit. And we can say heat is, so this is heat. Second point is, okay, this is heat is an energy in transit. Second point is non-mechanical way of transit of energy. Heat is non-mechanical way of transit. Heat is non-mechanical way of transit of energy. Why is it so? Mechanical way of transferring energy is what? That is what is work. Okay, mechanical way of transferring, mechanical way of transferring energy is work. Okay, we apply force and work will be done, energy will be stored. Likewise, so this is mechanical way of transferring energy. This is non-mechanical way of transferring energy is what is heat. So heat flow. Okay, so always when you think about heat, that is nothing but always the energy in transit. Okay, suppose if you take a container, okay, if you take a container, so if someone asks how much energy is there, how much energy is there in this container, we will say, we will mention about, yeah, kinetic energy is so and so, maybe 2 joule, potential energy is 4 joule. Likewise we can answer, but we cannot answer heat energy in this is 3 joule. Absolutely wrong statement. Okay, heat energy in container is equal to, suppose if we say 3 joule, this is wrong statement. Okay, so energy that resides in the body is either kinetic energy, potential energy. One more term we will be seeing in this topic, that is nothing but internal energy. So this internal energy can be there in the body, but heat energy will not be there. Once heat energy is given to the body, that will be converted into kinetic energy or potential energy, whatever be the kind of energy it has. Okay, so heat energy will be converted into what? Internal energy, once if we have given that to a body. Okay, so heat energy is given to the body, and that heat energy will be converted into what? Into its internal energy or kinetic energy. Okay, so we can say if a body is here, another body is here, we can say energy is transferred. So heat energy is transferred. Say for example, here it is 6 joule and here it is, say for example, 4 joule. Then what will happen? 2 joule can be transferred to this, and both of them will become this will become actually what will happen, till their temperature will become same, or till their energy becomes same. So if this is 5 joule and another body is there, if its energy is also 5 joule, then we can say 1 joule of heat is transferred to this. Suppose if its kinetic energy, if it was 4 joule, then this 1 joule is given to this body. What will happen? This is kinetic energy initial, the kinetic energy final will become 5 joule. Clear? So heat is nothing but the energy which is traveling. Always it is traveling, or any energy which is traveling we can call heat energy. Okay, clear? Okay, now we can say one thing, like suppose if this has got 32 degrees Celsius is the temperature. Okay, so this is a measure of hotness, measure of hotness of body. This is what is temperature. Okay, so heat will be, heat is energy in transit, and temperature is nothing but measurement of hotness of one body. Okay, let us take another example. Suppose if we keep an ice cube here, suppose if its temperature is 5 degrees Celsius, its temperature is 5 degrees Celsius. Okay, in your room. Okay, if you have taken an ice cube from the fridge and if you are keeping it on the table, what will happen? Its temperature will increase. Its temperature will increase. We need not do anything. Its temperature will increase. Then what will happen? This ice will become ice at 0 degrees Celsius, and what will happen? This will become water at 0 degree Celsius. So it was 5 degrees Celsius. Now its temperature is increased. Correct or what? Temperature is increased. So this is one scenario. Another scenario, suppose if you keep a cup of tea, say for example it is 80 degree Celsius, temperature is there. Okay, what will happen? Its temperature will come down. And it will come to what temperature? Let us take suppose room temperature is 27 degrees Celsius. What will happen? Its temperature will come down. And it will become cold compared to the previous condition. So in this case temperature was increasing, in this case temperature was decreasing. So why it is so? Because suppose if the surrounding temperature is equal to 27 degrees Celsius, this will melt and finally it will form water of temperature 27 degrees Celsius, and this heat will this tea will become what? Its temperature also will become 27 degrees Celsius. So if we keep an ice cube, temperature is increased, and if we took a tea, its temperature has decreased. What is happening here? So this is mainly because of heat exchange. Okay, the heat energy from this, okay, this has got less temperature, so the surroundings will give heat energy. And its temperature will increase. Finally it will become water. Here what happens? It has got more temperature, so heat will be delivered to the surrounding and it becomes temperature equal to the surrounding. So it is trying to attain thermal equilibrium. So in order to attain thermal equilibrium, okay, what it will happen? The exchange of energy will happen, or exchange of heat energy will happen, and finally both the temperature will become equal. That is what is called thermal equilibrium. Okay, shall I erase this? Okay, so this is what is zeroth law of thermodynamics. Okay, zeroth law of thermodynamics. Actually this law will come in the chapter thermodynamics, but already we have discussed here in the introduction, so I am just mentioning. Zeroth law of thermodynamics discusses about thermal equilibrium. Okay, so heat exchange happens till the system attains thermal equilibrium. Okay, the heat exchange happens till the system attains thermal equilibrium. System can be one body or two body or three body and its surrounding closed system. Okay, we can say till the system attains thermal equilibrium. For this we can say closed system. Clear? Closed system means whatever system we are considering. If it has external connection, again energy exchange will happen. Suppose if we take a closed system and if we set the temperature there, all the three bodies will have, suppose if we have taken three bodies, okay, and we close the system. Close the system means there is no exchange of energy will happen. Okay, if you take a flask, okay, there is no, inside the temperature will be constant. Why? Because no energy exchange will happen. No exchange, energy cannot either go inside or it can neither come outside in a flask. Okay, so temperature will be constant there. Okay, same way if we take three or four bodies, we sealed it so that no heat will happen in between. So inside the system, if the three bodies have three different temperatures, what will happen? Heat exchange will happen between them and all the three bodies will have same temperature once if we check it out. Okay, that is what is zeroth law of thermodynamics says. Okay, now students, so heat exchange is associated with the change in temperature. That is the reason many of us immediately, if we are asked, someone asked us what is the difference between heat and temperature, it will take some time to explain because this is associated. Okay, if we give heat, temperature is increased, so we will think that okay, heat and temperature both are same. Okay, now let us spend some time on the calculation of temperature. Okay, we calculate the temperature. In order to calculate the temperature, various scales were proposed. Okay, each scientist, they gave their own scales and we have got different scales in our day-to-day life. So Celsius scale is there, this much, how much is the temperature of a patient, generally what we say, this much degree Celsius. Okay, then SI unit which we use generally, okay, is what? Kelvin scale. Then Fahrenheit scale is also there. Okay, then Römer scale is also there. Many scales are there, so we will study about it. Before that we should understand like what were the criteria for defining these scales, and if we consider a thermometer, what were the points which we need to consider. All those things we need to understand. Okay, so what should be the criteria for defining a thermometer or a scale? Okay, they discussed a lot, they tried various things, and finally they concluded that generally what we should do, we will take two fixed points. Okay, fixed points are nothing but, for all the scales, the fixed points are nothing but the boiling point of water and the melting point of water. I mean, when I say melting point of water, means nothing but melting point of another form of water which is nothing but ice, or we can say the fusion point also. Okay, so melting point, boiling point, okay, these are the two fixed points, okay, of a scale. So in between how many divisions are there, okay, that also we will have to see. first I shall introduce Celsius, because that we have some connection in our day-to-day life. Say Celsius scale. So we fixed 2 fixed points. So this is called upper fixed point. Upper fixed point. What is this actually? Boiling point of water. Boiling point of water. So what is boiling point of water? Okay, we can boiling point of water. We know this is 100 degrees Celsius. 100 degree Celsius is the boiling point of water. This is the upper fixed point. Okay, maximum and minimum point. Upper fixed point, lower fixed point means maximum and minimum. If we take a thermometer, okay, maximum it can measure 100 degrees Celsius. Minimum it can measure 0 degrees Celsius. Conventional things I am saying, for specific purpose different gadgets will be there, different thermometers will be there. I am telling about the common thing. And here we have lower fixed point, and this is nothing but 0 degrees Celsius. Okay, we can say melting point of water. Okay, so this boiling point of water is same is the condensation point of steam. Okay, at the point where water boils, this steam also will be generated. So at 100 degrees Celsius, steam will convert into water also. These all things we are going to see in detail in this chapter, okay, and under another topic. But for your information, I am telling like boiling point of water is same. Boiling point of water is same as the condensation point of steam. Okay, same way melting point of ice is same as what? Fusion point of water. Means at this point steam will be converted into water and water will be converted into steam. If we give more heat, water will convert into steam. If we take heat, steam will be converted into water. Just an introduction. In detail we are going to see this. Okay, because some of the students who study, who think, may think, they may ask doubt. That is why I am telling you in advance. Same way, ice melts into water at what temperature? At 0 degree Celsius. If we give heat, ice will melt. If we take heat, water will become ice. Okay, so if this is water, if we take heat, what will happen? What is that? Ice. If this is heat, giving heat, what will happen to ice? That will become water. Now steam is there. Okay, what I am going to do? I am going to take heat. I took heat, that steam became water, raining. Okay, now this is water. What I am giving? I am giving heat to it. That will become steam. Okay, that will become steam. That is what I have written here. So this boiling point of water is that melting point of water means nothing but melting point of ice itself, another form of water. So this is upper fixed point and this is lower fixed point. How many divisions are there between 0 to 100? 100 divisions are there. These all are what? 100 divisions are there. Okay, so from 1 to 100, 100 divisions are there. Same way, if we take Fahrenheit, another scale. So in this case, in this scale, again same concept only. Upper fixed point for this one, it is actually 212 degree Fahrenheit. Okay, another scientist, he developed this scale and in his scale at 212 degree Fahrenheit water boils, and in his scale it is at 32 degree Fahrenheit. What will happen? The ice will melt, or we can say melting point of water. In between them, right from 33 till 212, here 100 divisions are there. In this case 212 minus 32, we will be getting 180 divisions. 180 divisions. Clear? Last one, another Romer scale is also there, that we need not discuss here. In the question we will discuss that also while we do problems. This is Kelvin scale. In Kelvin scale, what happens? Again, at 100 degrees Celsius in Kelvin scale, this is 373.15 Kelvin, and this is upper fixed point or boiling point of water. At here, at lower fixed point or melting point of water for Kelvin, this is going to be 273.15 Kelvin. So again, here also, how many divisions are there? From 273.5 to 373, we have 100 divisions. Okay, so these are the criteria they have taken. Okay, note it down. Okay, so these are the criteria they have taken. Okay, why they have taken like this? Because this is what is convenient. Okay, just we should have which material we should take. Okay, so they have taken water. They have taken water and they have fixed these points like that. Okay, so another scales are also there, but we need to study these scales are discussed in our text, so we will be concentrating only on this. Okay, and suppose if another scales are taken, for that also this is the methodology to follow. Upper fixed point, lower fixed point. Upper fixed point where water boils, lower fixed point where ice melts. How many divisions are there? From this one to this one, integers, digital, just like quantized values, 1, 2, 3, 4 likewise, not 0.5, 0.2, 0.3, we need not consider. This is 273 generally we take for accuracy purpose. Correct value is actually 273.5. While we discuss problems, we will ignore this 0.15 value. Okay, so this is what, clear? Fine. So under that okay, at one point where 0 Kelvin will come, here this is going to be minus 273 degrees Celsius. First minus 273 Celsius, the absolute zero, this is called absolute zero, and Kelvin scale starts. Lesser than 0 Kelvin, there is no temperature. Why is it so? Why can't we have minus 1 degree Kelvin? That I will explain. Okay, plus you can note it down. Okay, done. Okay, next important point which we need to discuss regarding the same topic is nothing but conversion. If we get 30 degrees Celsius, how can we convert into Kelvin? That is fine, because already we have used it. Just add 273, that is fine. But different scales are there. Fahrenheit scale is there, Romer is there, or if they give a faulty thermometer, calibration is faulty, then this much degree Celsius will be what value in degree Celsius itself in the correct thermometer. Likewise, we can have so many questions. So how to deal such situations, that we will see now. Okay, I am taking a graph x-axis. Okay, see students, now here y-axis Fahrenheit scale, x-axis Celsius. So x-axis is from 0 degrees Celsius to 100 degrees Celsius. Fahrenheit, it starts only from 32. So 32 to 212. So this overall, the temperature ranges from 32 to 312. Okay, 32 to 312. So since it is x-axis Celsius scale, it starts from here to this one, Fahrenheit from here to this one. Suppose if I mark a temperature. Okay, so this has got a value in Fahrenheit scale. The same value will be there in Celsius, degree Celsius also. So this temperature is common. Okay, say for example, if this is 40 degrees Celsius in Celsius scale, will have some equivalent value in Fahrenheit scale also. That we need to understand. There is a direct formula for this. That formula only I am explaining here. So how it comes? Okay, so suppose if we take the slope of this line, so from here to here, from here to here, or from here, wherever I take, this slope is constant, right? See, this theta is constant throughout. So slope is constant. Slope is constant. So how to take the slope? So from here to here, if I consider A and B, suppose if I consider A and B, the slope is what? y2 minus y1 divided by x2 minus x1. This is what is slope. Okay, so y2 is what? y2 is 212 minus y1 is what? 32 divided by what is x1 minus x2? X2 minus x1. x2 is 100, x1 is 0. So 100 minus 0. This is equal to. Now I can find with respect to this also, with respect to this line. So if I consider AF, okay, from here to here, if I consider what is y2? y2 is nothing but F minus what is y1? 32 divide by what is x2? C. This for this one, x2 and y2 are what? x2 is 100, y2 is 212. Here at this point, x1, y1. x1 is 0, y1 is 32. If I take this point, x2 and y2, if I consider x2 and y2, if I consider x2 is C and y2 is F. That is what I am trying here. Okay, so F minus 32. Okay, F minus 32, y2 minus y1. Okay, this is y2 and this is y1. This is y2 and this is y1. This is x2 and this is x1. Now I need x2 minus x1 for this point. So that is nothing but C. What is x2 here? C minus 0. So C minus 0. So just to take this, okay, I am putting this one here, this one here. So F minus 32 divided by 212 minus 32 is equal to C by 100. C by 100. So finally I will be getting C by 100 is equal to F minus 32. What is this? This is 180. This is 180. So between Celsius scale and Fahrenheit scale, I should follow this equation in order to do conversion. Clear how I am getting this? Clear? So in the same way, I can put Kelvin, Celsius. So I will be getting same relation I will be getting for Kelvin as well as degree Celsius. So I am extending this to a generalized formula and I will explain. Shall I erase this? Okay, pause the screen and note it down. So for 0 degrees Celsius, the lower fixed point for Fahrenheit is 32 degree Fahrenheit, and for Kelvin roughly we are writing 373 degree Kelvin. Okay, then upper point is 100, here 212, and here it is 373. Here the divisions are 100, here the divisions are 180, here the divisions are 100. So from this what we can say, C, okay, the random value, okay, then equivalent any value, any temperature, okay, any temperature in Celsius scale, okay. So this is equal to C minus lower fixed point. So that is what we had written, like C minus 0 we have written, divide by, we had written like 100. Okay, I will write the formula first, then we will generalize. So C minus 0 divided by 100 minus 0 is equal to, we have written F minus 32 divided by 212 minus 32. In Kelvin, if we take this, we are going to get in the, if we take Kelvin in the y-axis and C in the x-axis, what we are going to get is K minus 273 divided by 373 minus 273. This is what we are going to get. Or in x scale, what we are doing is x minus lower fixed point divided by upper fixed point of x scale. Okay, suppose if it is x scale, x minus lower fixed point by upper fixed point minus lower fixed point of x scale, this is equal to, for C alone lower fixed point is 0, so C by 100, this is equal to what, F minus 32 divided by 212 minus 32 is nothing but 180, and for Kelvin this is going to be K minus 273 divided by 100. So any conversion can be done, between these formulae. Any conversion can be done using this one. If this is x scale, this is degree Celsius, this is degree Fahrenheit, this is degree Kelvin. Clear? Understood or what? Okay, so if we get any faulty thermometer also, this thing we can use. Okay, if we get a faulty thermometer, in the faulty thermometer upper fixed point, lower fixed point, okay, whatever be the current value, all those things we can put in the formula. Okay, and we can put the right hand side which conversion we need to do. Okay, so here in the same thing, okay, if this is degree Celsius, if this is degree Fahrenheit, okay, if this is 32 and this is 212, okay, this is 0, this is 100. Okay, so if we draw a line here, we have seen this is slope, okay, 100, 212, and this is 0, 32. If we take any point, okay, so this is Fahrenheit scale and this is Celsius scale. Suppose if we take the difference of temperature, if we take 2 points, and we want to know the change in temperature, suppose if this is F1 and this is F2, okay, F1 and F2, and this is C1 and this is C2. So between them, if we take the slope, the slope will be same. Okay, say for example, here the slope is, here the coordinates are what, C2, F2, here the coordinates are C1, F1. So the slope is same. Slope is same because this is what? Straight line. This is straight line. Clear or what? So a slope is same and it is straight line. So the same formula can be used in order to find the change in temperature also. Say for example, delta F if we take, delta F divided by 180 will be equal to delta C divided by 100. So this is same as delta K divided by 100, or any other scale, delta X divided by the number of divisions. Number of divisions. So hope you understood. Okay, from the previous figure itself we can get the same thing. Okay, same thing. Okay, if you want I can show you the slope of this line is what? Slope is equal to what? F2 minus F1. This is Y2 minus Y1 divided by X2 minus X1 is what? C2 minus C1. This is X2 minus X1. This is equal to, what is the non-slope for us? We will take these 2 points. This is nothing but 212 minus 32 divided by what? 100 minus 0. So this can be considered as delta F. Delta F divided by, this will come here, 180. This is equal to what? Delta C by 100. We are getting the same value. Clear or what? So this can be extended to any other scale. If you get any other scale which we do not know, okay, any scale with any name, okay, M scale or T scale, then what we need to do? We need to find the change in the temperature, means we compare with any other scale. But here on the denominator we should have what? Number of divisions. That is how to find the number of divisions. Suppose if they say upper fixed point or boiling point of water in this scale is 400, lower temperature, that is lower fixed point, melting point of ice is 200, then 400 minus 200 is how many? 200. So 200 will be the number of divisions here. So when we do problems you will become very comfortable. Okay, is it clear? Okay, so this is the part of thermometry where the conversion of different scales are involved. Okay, different problems will we can solve from this area. Okay, so this is the basic understanding, basic theory of this topic. Now we will do problems. So we have started thermal properties of matter. In thermal properties of matter, we were discussing the very first topic, which was thermometry, the measurement of temperature and various scales we use in order to measure the temperatures. Then how to convert one scale, a temperature, a measurement of temperature, that is a quantity in one scale to another scale. Okay, how to convert it, how to convert the change in temperature in one scale in another scale. All these things we have discussed, its theory part, how it came and all. Now in this session we will do some problems on that. Okay, so before doing the problems, let us quickly go through how to convert each scale into another one. So general point is, a value maybe X in one scale, how to convert into another one. So X in that scale may be a faulty scale or maybe some other scale, minus lower fixed point divided by upper fixed point minus lower fixed point. This is equal to, suppose if we want to convert this into Celsius, then what we do? C is its respective value in degree Celsius. Okay, X in some other scale will be equal to C in Celsius scale. That is the idea. C minus lower fixed point divided by upper fixed point minus lower fixed point. So if we put the values exactly, lower fixed point is 0, upper fixed point is 100,
and lower fixed point in Celsius scale is 0. What is upper fixed point? The boiling point of water. Lower fixed point is the melting point of ice. Okay, and this is equal to, in Kelvin, K minus lower fixed point is 273 divided by upper fixed point is 373 minus 273. So this one we write C by 100. Same way in Kelvin, what we write? K minus 273 divided by 100. Okay, number of divisions. So this one we can write in this way also, x minus lower fixed point divide by the number of divisions in that particular scale. Okay, and this is equal to, in Fahrenheit, F minus 32, and here upper fixed point is 212 minus lower fixed point is 32. So 212 minus 32 will be what? This is equal to F minus 32 divided by 180. Okay, so this 180 is the number of divisions, 100, they are the number of divisions respectively. So the very what details we need in order to solve the problem is x minus lower fixed point divided by upper fixed point minus lower fixed point. Okay, this is equal to C by 100. This is equal to K minus 273 divided by 100, and this is equal to Fahrenheit, F minus 32 divided by 180. So if you can recollect, and if you can understand these many details, then we will be able to solve problems based on this. Okay, now we will move to problems. Okay, so the first problem is a faulty thermometer. This is faulty thermometer. A faulty thermometer has fixed points marked as 5 degree Celsius, 5 degree and 95 degree. This is a faulty thermometer. We do not know its proper which scale and all. Upper fixed point and lower fixed points are given. Okay. The temperature of the body as measured by the faulty thermometer is 59. Okay, in that faulty thermometer, some temperature is measured as 59. Find the correct temperature of the body in Celsius scale. So, what is the formula to use here? X minus lower fixed point divided by upper fixed point minus lower fixed point. This is equal to which scale we are going to convert. So C minus 0 divided by 100 minus 0. Okay, now we will substitute. So the temperature of the body measured by the faulty thermometer. Okay, faulty thermometer is 59. So 59 minus, they have given like its lower fixed point as what? 5 degree and 95. So 5 is the lower one, 95 is the upper fixed point, again 5 is the lower fixed point. This is equal to C by 100. So C will be what? This is going to be 54 divided by 90 into 100. So if you simplify this, okay, we will be getting what? So 9 will be there, 6. So 60 degrees Celsius is the answer. Clear? So faulty thermometer or any other scale, we can write it as x minus LFP divided by the number of divisions is equal to which scale we need to convert. We can put like that. Okay, hope this is clear for you. Next problem is temperature of a patient is 40 degrees Celsius. find the temperature on Fahrenheit. So 40, Now hereafter, I need not write 40 minus 0 by 100 minus 0 and all. Anyway, this is understood. 40 by 100, this is equal to F minus 32. For Fahrenheit, what? 232 minus, sorry, 212 minus 32. So 40 by 100 is equal to F minus 32 divided by 180. Okay, that is enough. Now what is F? F is equal to, this will be cancelled off. So 4 divided by 10 into 180, whatever we are going to get, plus 32. Okay, so 18 into 4 is what? 72. And 72 plus 32, we will be getting 104 degree Fahrenheit. Okay, option A is the answer. Previous one, option C is the answer. C is the answer. This one, option A is the answer. Clear? Okay, shall we move to the next problem? Yes, a thermometer has a wrong calibration. Okay, wrong calibration means when they make that scale, okay, it will be based on some expansion. When temperature increases, either volume, pressure, or something, some physical quantity will be varying. Based on that only they make thermometer. So wrong calibration means the expansion and the increase in temperature, that measurement marking, everything gone wrong. That's what. Okay, a thermometer has wrong calibration. It reads the melting point of ice as minus 10 degrees Celsius. It reads 60 degrees Celsius in the place of 50. So calculate the temperature of boiling point of water on this scale. Okay, do this question, pause the screen and do the question yourself, then verify the answer. Okay, so pause the screen and do yourself. Okay, you got the answer. Now we may get a temptation like if that melting point is minus 10 degrees Celsius, in Celsius scale anyway the number of divisions is 100, so minus 10 plus 100 we may get 90. 90 is there in the option also, so immediately we may feel to go in that way, but that 90 is a deception. Okay, it will give us negative marks, because when you put in the formula, if you put in the formula, the things will be different. Okay, let us see. So now the faulty thermometer. Okay, now what they are saying is it reads 60 in the place of 50. So 60 is a reading in this faulty thermometer, that minus lower fixed point divided by upper fixed point minus lower fixed point. This is equal to, they're asking to calculate the temperature in temperature calculate the temperature of the boiling point of water on this scale. Okay, so it reads 60 degree in the place of 50 degree. So actually they need in degree Celsius. Look at the options, they need the answer in degree Celsius. So left hand right hand side we can put C by 100. Right, so 60 minus lower fixed point according to this wrong calibration, let us take it as a different scale. Melting point is given as minus 10, so let us put lower fixed point minus 10 there. Upper fixed point, we need to find it out. Upper fixed point we need to find it out. Minus lower fixed point is minus 10. It reads 60 in the place of 50, so 50 is the correct reading, 60 is the one which is showing in this scale. Okay, so we will be getting now, this is going to be 60 plus 10, 70. Divide by what? We need to find boiling point. Boiling point is what? Is the upper fixed point. So boiling point plus 10. This is equal to what? 1 by 2. So boiling point plus 10 is equal to 2 into 70. So boiling point is going to be 140 minus 10. We will be getting 130 degree in what? On this scale. Okay, in the wrong calibration. Getting or what? Clear? So in the wrong calibration, melting point of ice is minus 10. It is wrong. It reads 60. Okay, we need to find the boiling point of water on that scale. Okay, in that it will be showing as degree Celsius, but the correct one will be 50 in the place of 60. Okay, so we are equating to Celsius scale and solving this. Is that clear? So this is next question, students. At to what temperature is the Fahrenheit scale reading is equal to twice of the Celsius? Okay, so Fahrenheit scale reading is twice of the Celsius. So here 2C. Okay, we can put 2C minus 32. Okay, what I am going to write is F minus 32 divided by 180 is equal to what? C by 100. So instead of F, I am putting 2C. The magnitude of that reading will be twice that of Celsius. So 2C minus 32 is equal to by 180 is equal to what? C by 100. So uh, C is equal to what? Or 2C minus 32 is equal to 18C, and 10 will come here. So 20C minus 320 is equal to what? 18C, and 2C is equal to 320 we will be getting. C is equal to 160 degree. So 160 degrees Celsius, that is also fine, or otherwise it will give the value of 320 degree Fahrenheit. Both are same temperature, same hotness. Okay, if we touch, how much feel we are getting? If it is 160 degrees Celsius, same hotness will be there for 320 degree Fahrenheit also. Okay, so this is about that. This is the answer for that question. Option C is the correct answer. Okay, next one. The lower fixed point and upper fixed point of a faulty thermometer are 5 and 105. Lower fixed point and upper fixed points of a faulty thermometer are 5 and 105. If the thermometer reads 25, what is the actual temperature in the Celsius scale? So if its reading is 25, okay, minus lower fixed point is given as 5, then upper fixed point is 105 minus 5. Okay, x minus lower fixed point divided by upper fixed point minus lower fixed point is equal to whatever be the temperature. So C by 100 here. So here this is going to be what is the actual measurement in Celsius scale. This is what we need to find, C by 100. So 20 divided by 100 into 100 is equal to C, which is nothing but 20 degree Celsius. Option A. Clear? Shall we move to the next question? Yes. The temperature of an iron piece is raised from 30 degrees Celsius to 90 degrees Celsius. What is its change in its temperature on Fahrenheit scale and Kelvin scale? So in Kelvin scale, I think without these basics also you will answer. Okay, we are very much habituated to Kelvin scale and degree Celsius. Whatever change happens in degree Celsius in Celsius scale, the same change will happen in Kelvin scale also. That we know. Okay, but let us try. So here already we have seen delta C by 100. Okay, change in temperature in Celsius scale divided by number of division. This is equal to what? Delta K. That is change in temperature in Kelvin divided by its number of division. This is the actual formula which we need. Okay, so delta C is what here? 90 minus 30. So this is equal to what? 60. This is same as delta K. So that one is done. Okay, so another part is this is done. Next part is Kelvin, Fahrenheit. So delta C by 100. This is equal to what? F delta F. Delta F divided by number of divisions. So here the number of divisions is 180. Number of division is 180. So delta C we know that is 60 divided by 100 into 180 is equal to delta F. Okay. So 0 will be cancelled off. So 18 into 6. So 18 into 4 is 72. 72 plus again 36. So 108. 108 degree Fahrenheit is the change in Fahrenheit scale. 108 and 60. Answer is B. Okay. Correct answer is B. Clear? Shall we move to the next problem? Yes. A thermometer with an arbitrary scale has the ice point at minus 20 degrees Celsius and the steam point at 180 degrees Celsius. Okay. Steam point means that boiling point. Ice point is nothing but the melting point. So when the thermometer reads 5 degrees Celsius, the centigrade thermometer will read what? That is a question. So C by 100, this is equal to, so this is the arbitrary scale. What will be its reading in arbitrary scale? Okay, ice point is minus 20 and thermometer reads 5 degrees Celsius. So 5 minus, its lower fixed point is given as minus 20 and upper fixed point is 180 and again minus 20. Okay, so C by 100 is equal to 25 divided by 160. So C is equal to 25 by 160 into 100. Okay, so this is what? Okay, so 250 divided by 16. Okay, 250 divided by 16. So 250 divided by 4 divided by 16. Likewise, you can calculate. This is going to be 12.5 degrees Celsius. 12.5 degrees Celsius, option B. Okay. Okay, similar type of question. Okay. Next problem is, we do not know about this scale, but they are asking a rumor for rumor scale. The point is 0 degree rumor and steam point is ice point is 0 degree rumor and steam point is 80 degree rumor. Find the value of 20 degrees Celsius in terms of rumor. Okay, so 20 by 100, this is equal to the value in rumor scale which we need to find. So ice point is given as 0, that is lower fixed point. Upper fixed point is 80, then that minus 0, over, done. So R is equal to 20 by 100 into 80. So 0, 0, 0, 0, everything will be cancelled out. So 16 degree R. Okay, rumor scale only they are asking. So 16 degree R will come, should come in the option. Option C is the answer. Clear? Next one. Okay, a centigrade and Fahrenheit thermometers are dipped in boiling water. Okay, two thermometers, one is in centigrade, the another is in Fahrenheit. They are dipped in boiling water thermometers. The water temperature is lowered until the Fahrenheit thermometer registers 140 degrees Celsius. Okay, so after dipping, after some time, naturally the temperature of the water came down. So that time Fahrenheit thermometer was showing 140 degrees Fahrenheit. What is the fall in temperatures as registered by centigrade thermometer? Okay, that is the question. Okay, so here we can understand that boiling water, this is boiling water. In boiling water, what will be the temperature in degrees Celsius? Will be 100, boiling water. So same way, upper fixed point of Fahrenheit is what? 212 degree Fahrenheit. So new temperature. Okay, new temperature measured. This one we do not know. Here they have measured 1 to 40 degree Fahrenheit. Now, what will be the measurement in Celsius is what the question is. Now, what we can understand is from this to this 212 to 140 degree Fahrenheit, what is the change in temperature? Um, 212 minus 140. 212 minus 140 is how much? 212 minus 140, how much is the change? 54 degree change or what? Sorry, 212 minus 140 is 72 degree Fahrenheit is the change in temperature for delta F. Fine. So delta F divided by 180, this is equal to what? Delta C divided by 100. So what is the fall in temperature as registered by the centigrade thermometer? That is delta C is what the question is. Okay. So delta C is what? Delta C is equal to 72 into 100 divided by 180. So 0 cancel. This is 4. So 40 degree Celsius is the change in temperature of a centigrade thermometer. Okay, 40. So here options are wrong. Okay, just take one option as 40 degree Celsius. Clear? Understood or what? Okay, instead of directly saying this is the change in temperature, they have given a practical situation. That's it. Okay, next problem. The absolute zero temperature in Fahrenheit scale is the absolute zero temperature in Fahrenheit scale is. What is absolute zero? Absolute zero means 0 Kelvin. In Kelvin, uh, we say absolute zero. Okay, 0 Kelvin. So, what is its value in Fahrenheit? So, we can say F minus 32 divided by 212 minus 32. This is equal to absolute zero is 0 minus 273 divided by 100. Okay, or 373 minus 273. So F minus 32 divided by 180 is equal to minus 273 divided by 100. So F minus 32 is equal to minus 273 into 180 divided by 100. So F is equal to minus 273 into 18 by 10 plus 32. So simplify this, we will be getting minus 459.4 degree Fahrenheit. So option C can be taken as the correct answer. Okay, clear? So 0 Kelvin is the lowest temperature possible. Okay, beyond that there is no temperature value. We will discuss that later. That is a fact now, just for your understanding. So that is what absolute zero. Clear? Okay. So next question is, in which of the following scale temperature can never be negative? From the previous information, you can say very well that Kelvin, we don't have negative scale. Next question, using which of the following instrument the temperature of the sun can be determined? Okay, the answer is pyrometer, option 3, pyrometer. So in this chapter, after finishing the theory topics, backside NCERT exercises are there. In that, regarding measurement of the temperature in black body, one question they have given. So in that, even though in NCERT in the theoretical part, then nothing is written regarding pyrometer, but in the backside exercise, pyrometer they have mentioned in a question measuring the temperature of the black body. Okay, so obviously if it can measure the temperature of black body, it can measure the temperature of sun also. Application oriented question. From a sentence they can make a question and ask, so it is better if we understand it now. Okay, so measurement of the temperature can be temperature of sun can be determined using pyrometer. Okay, so students, so this is the information problems regarding our thermometry. Okay, the conversion of scale and all. Okay, so please practice and make the concepts ready. Okay, thank you, bye bye, good luck.